Alright guys, welcome to our today's tutorial. Alright, let's try to look at this question together that came in one of the past papers. Alright, so here this is they're saying propose a reasonable mechanism for this reaction. Okay, so when you look at this guy here who is here, the one that we are synthesizing, we are going to look at it nicely. You find that this is what we call imidazole. This is what we call imidazole. Okay, so imidazole, the synthesis of imidazole is very tricky, but it's very simple. We need just to look at it nicely and practice on that. Yeah, so what we're going to do, we have this one which is a ketone here with an alcohol with hydroxy there, and we have this guy here. Okay, so what you're going to do here, the first thing that you're supposed to look at is I can just write this which is here like this. So here I'm going to write mechanism. So here I'm going to write mechanism like that. Then here, okay, so good, like this. Then here there's CH3, then here OH like that. Okay, so when you reach at that point, you bring up these reagents which is there. You see, I can even write this reagent and the, well, how can I write it? Okay, very easy. I can write it like this is N with how many hydrogen? 2 hydrogen connected to this carbon there with the oxygen there and the 1 hydrogen. That's the best way you can write it, you get? So what will happen is that you are going to bring these electrons here, or lone pair of electrons, which will come and attack on the nitrogen, on the carbonyl there, which has a carbonyl containing which is a carbonyl which has got the carbonyl group. So there, what you're going to have, this. Okay, so I can even write like that. You're going to have okay, let me write it here. You're going to have like something like this. Then when you react, this one will open, right? Don't forget this guy. When you react on this one will open so that the bonds can be stable. So here I'm going to write this oxygen there. It has opened. Then here is CH3 there. Then here you have OH like that. Okay, so here is a reasonable mechanism. There are some other mechanism you find on this one. So here there is the nitrogen with 2 hydrogen there, then like this. Okay, so something like this. When you check nicely, you find that this guy here is going to have a positive, right? Because it is unstable. It has got 4 bonds, supposed to have 3 bonds. There will be an intermolecular reaction. This guy will come and attack this so that it can be stable. This guy is very single here. He needs someone who is a partner. So here what will happen, this one, when you get this hydrogen to make someone stable, this one is stable, then just like that, you get? So make sure that this will come and will come direct to the what? To the nitrogen there. So what we are going to have, we are going to have this hydrogen there, then something like that, then nitrogen with only 1 hydrogen there, then here with this one, okay, which is like that. Then here we have OH. Then this guy here, we can say it has got CH3, then OH like that. Okay, we are still moving, yeah? We are still moving. So we want to remove this hydrogen which is here, or that's not hydrogen, but we want to remove this guy who is here, who is called the OH there, because in our product, when you look at our product there, check, there is no any OH there. So what you are going to do is just to use this lone pair of electrons and get this hydrogen. Then this one will do what? The electrons will go toward the oxygen. So I'm going to rewrite it again, which is hydrogen. Then here it's like this, then nitrogen with 1 hydrogen, then here there is pH there, like this. Okay, my pen is not writing well, but I'll try. Let me just write well. Okay, like this. There's nitrogen there. Then what will happen to this? There is phenyl. Then here you are going to have something like H2O, which means has got 3 bonds like that. Then here you're going to have CH3, and here this guy who is called the oxygen. Again, oxygen there is not stable, right? So there will be something that will happen here. This guy will come back here and make a double bond. You get? When he makes a double bond, there will be, you know, here when he makes a double bond, there is a proton here. There is a proton here. You see? There is hydrogen there. I can even show it even here. There is hydrogen there, which you can't see, but you should know that there is hydrogen, right? So this hydrogen here, even if you show it or you don't show it, is there. Then here, that's the hydrogen. When you make a double bond here, will come and make a double bond there. So this, when you make a double bond on the oxygen, this will come and make a double bond there. This guy will do what? Will break, and all the electrons will go toward the oxygen, and we're going to have water there. You see, you have made some water there. So, but there will be, immediately when this reaction happens, there will be what we call a proton what? A proton transfer, which means that here, where there is a double bond, which the double bond which I've made here between here, which you have made a double bond here, I'm sure I've made a double bond there, it won't even be seen because we are going to add a proton there, and the double bond also will disappear. So we are not going to show a double bond there. It will be just like this. N here with hydrogen there. Then here we are going to have where we have removed water there, yeah, we're going to have hydrogen. Then it will be like this. Then what we are going to have, we are going to have this, which is CH3. Then here with the like that, you get, because we have made a bond here. So this guy will come here. We have made a bond. This negative made a double bond there. Then this charge has made this hydrogen made a double bond, and this guy has gone. But before even the product has been formed, there is a proton transfer, which we have added the proton where we have just removed the water there, and the double bond which was supposed to be there has shifted. The double bond which was supposed to be there has shifted. So that's what we are going to have there. So at this point, we are going to see that on the reagents that we are having there, we are having 2 reagents, which is these guys here. There are 2 of them. So we have just used one, the one that we reacted at here. So we can bring another one there. We can bring another one there, which I can even write it like any. The way I've written it at first, it is like this. Then we have hydrogen, you get. So these lone pair of electrons are the one that will come and react on the carbon there. So this one will come and react on the carbon there, and making this one to do what? To open like that. Okay. So at this point of time, we are going to use this here, which is nitrogen, you get. Then here we're going to have this phenyl, then with hydrogen there. Then here we have this CH3. Then here with the one that has just opened here, you've seen the one has opened. Then I'm just going to add this now, which is the nitrogen with how many hydrogen? 2. Then here we have C like this. You see? So this one again is not stable. When you look at this one has a positive charge because it has got 4 bonds. Then this one also is a single partner, which needs to have another partner for it to be stable. So this guy will come and get this hydrogen. Then what will happen to this? The electrons will go toward what? The nitrogen, to make this nitrogen to be very stable. You reach at that position. Now we are going to say, okay, let me write now what I've remained with. Is this guy here like this. Then here is nitrogen. If you want, you can now write this one is like this. This one is CH3. Then here is CH3. Then here is nitrogen with one hydrogen. Then here is C. I want just to make it now a ring, but I want us to come up with that, you see. So where there's methyl, that's where there's OH, right? Okay, where there's methyl, there's OH like that. Okay, even here there's hydrogen like that. This is the same thing that I've written, but you can see right like that, you get? So that's the one that I'm going to have right now. So if you want, you can just put it straight like that. If you want, you can put it in anywhere, but we're going to arrive at the same product, you get? So there at this point, we need also to remove this OH. It's not there in the product, so we're going to use these lone pairs and get this hydrogen there. What will happen to this hydrogen will come and make it the electrons here will come to this carbon there, which will make it now electron, it will be electron rich, you get? So here what you're going to have this, then here nitrogen, here we said this one is phenyl, then with a negative there, because we have removed the proton, right? So it's, there's a negative there on the carbon. Then here there's CH3 like that. There's CH3. Then here here there's OH2 with a positive like that. You've seen, huh? That's this now, which is here. Then here the nitrogen here with one hydrogen. Then here with a C, something like this. Okay, so at this point now we need to make this guy to come to leave this water. By these electrons which are here, which are not stable, will make a double bond. How can we make this to be a double bond? It will make a double bond there, making this one to leave like that, you get? So what you're going to have this nitrogen. Then here we have like this. We have this, which is if you want, you can use it like this. Okay, this here, which is like that. Then with a double bond there, which we have made there. Then here CH3 like that one. Then we have N there with a one hydrogen. Then we have C here with it like that. So if you want, at this point now, you can get any of the nitrogen which are there to react, you get? To react with a carbonyl group, you get? So here, if I want, I can say, at this point where I am, I'll get this nitrogen, which is the carbonyl, or this nitrogen, with this lone pair of electrons to come and react on this carbonyl here, which is there. What will happen to this guy is that when I react here, this one will open like this. That's how you're going to show it. When you react there, this one opens. Then the product that you're going to find. So here I'll start with this nitrogen, right? So you can just see here, I'm going to start with this nitrogen with the one hydrogen there. Then this one here, which is here, this one is there, so you can try to look at it. So okay, so here this is the nitrogen. Then here there is this bond there, you've seen, where this bond will connect to this carbon there, which has got a methyl there. So there I'm going to say this one has got a methyl like this. Then there's a double bond there, and to reach to this carbon that has got a phenyl, to reach to this carbon that has got a phenyl like that, you get? So here there's another, after carbon there's another nitrogen there, and nitrogen, then there's a carbon that is connected to this nitrogen. So here I can do like this. Here there is a nitrogen, which is this nitrogen there, because this carbon that has got a phenyl is this one. Then this nitrogen is there. which I've written there. Then there is a carbon now here, which has got this one, which has opened, connected to this nitrogen. So what I'm going to do is, this is the carbon which has got this, which has opened, connected to this nitrogen now. That's here, which I've made here. You get? So at this point, you have seen that this carbon here, which you have started with here, it has also this guy here, who is here. Don't forget about that. So what you are going to do when you reach at that point now is to make sure here you've seen that this one has got this. So here we have said the nitrogen is this down, which is this nitrogen, together with this guy who is here. So when it makes a double bond, we say this nitrogen is connected to this carbon, which has got methyl. That is this one here, this, you get, has got methyl. Then you find a double bond here to this carbon that has got phenyl. That's this one with a double bond that has got phenyl there. Then you go ahead there, you find that there is a nitrogen with a hydrogen. That is this nitrogen with a hydrogen. Then here you find that there's a carbon here which has got oxygen that has opened here with a negative, now of a negative, connected direct to the nitrogen there, which we started at first. That is this carbon here with oxygen which has opened, connected direct to that. So it's not stable as well. So what will happen to this guy? We are going just to get this hydrogen there, making this to come on the nitrogen like that, you see. So we are going to have this CH3. Okay, so let me just show it nicely. No, it's not supposed to be like that. It's supposed to be like this, with a negative there. Then here it has got a positive because of this one here. So we're going to find it like this. So here with a positive. Why? Because of this, it has got 4 bonds there. It's supposed to have 3 bonds for it to be stable. So at this point, it will have a positive like that. So what we are going to do there, then here there is the OH, you've seen, because you have made OH there. So what we are going to see there, we're going to say we want to remove so there are some ways in which you can do that. Sometimes you can start with this, reacting with that, or sometimes you can first get this one and react with this, so that this guy can be neutralized. It's the same thing, you can start with that. So this one will be neutralized like that. But there are some people whereby they will start with this one to come and react with this, then this one neutralize. After that, now they use this and get this nitrogen. It's okay, it's fine. You get? It's fine. You start with any. So I'm sure you understand. What I mean is you can let me just show you what I mean is that you can do like this. Okay, I'm not supposed to rub this. I'm not supposed to rub this. So what I mean is that here you can have your hydrogen like that, then here with oxygen like that. Here they see, then your hydrogen like that. So if you want, you can start with this, reacting with this. You get? Then what will happen? This one won't break. This one will come here and make a what? Will neutralize that charge there. So it's the same thing what we said. So we can even show it from there on top there. You can even show it there. So here you see, you can even show it there, so that we come up with a good product here. Like this is a negative, the one I was saying, you come and react it here, then this one will come and neutralize that one. Then here what you're going to have, you're going to have this, then with this now like this, you get. So these lone pair of electrons are the one that can come and get this nitrogen there, which is the same thing. If you had started with this one, you would have even gone to this direction. So this one, you come and make an electron there, or it will be, so here N, then here a double bond, then here we have CH3, then here N like this, okay, with a negative there, see. Then here you're going to have O. Okay, so you're going to have oxygen with the hydrogen there, then together with this. Okay, so when you reach at that point, this guy will going to have a positive like that. So what you're going to do is just to use these bonds or these electrons and make a double bond there, and this one will do what? Or will go like that. So when it goes, here you have a double bond. So here, make sure the double bond, you show it like this one, make a double bond there, then this one will go like that. So what you're going to have as your product, so make sure you write an arrow there, you see, like this. Oh, sorry, it's like this, CH3, then here N with hydrogen there, then here with a double bond there, here there's N with a double bond there, like this. I'm sure that's how this product, when you, this one will go, then we are going to have this. Plus, don't forget, you're going to have, remember when you get this one has gone, you have this, which is CO, O, then you have hydrogen. So here I can say I have hydrogen with CO, O, hydrogen, like this. So this is the product that you're having together with this. When you check nicely, you're going to find that this is exactly the product that you're having, you get. And this one, is there a double bond there? Did we write a double bond? Okay, yeah, all the double bonds are there. So this is imidazole. That's the synthesis of imidazole. But yeah, that's the synthesis of imidazole, like this. All right, so thank you so much guys for watching this video. Stay blessed.